Hey, welcome back. Today we're taking a look at what it means when we actually draw a trend line through a scatter plot and then use it to make predictions. Now in the last lesson, you saw this graphic that shows what a scatter plot might look like when you have a positive association where you see the dots are increasing to the right. And then we looked at a negative association where it looks like the relationship is showing that when one quantity goes up, the other one goes down. And then you looked at scatter plots that don't really have a pattern, and so we can't really draw a trend line. And you can't really use a no association scatter plot to make a prediction. If I were looking at trying to draw a trend line through this positive association, we want to make sure that a trend line goes right through the middle of all the dots. And we might come up with a scatter plot that looks something like that, or a trend line, I'm sorry. And on this negative association, it looks like my y-intercept is probably up here somewhere. And I want to draw that line that kind of goes through all these dots. And notice, I didn't really make too much alteration for this dot here. This dot literally kind of looks off the pattern a little bit. And on this no association, you can't really draw any kind of a trend line through that at all. So here we have an example where we have some running data for Joyce. Joyce is running, in this example, she runs 4 miles and it took her 38 minutes. And then when she ran 2 miles, it took 25 minutes. And I am going to take just a minute here and scatter these dots on the graph. Okay, we're going to go ahead and draw a trend line through all these dots. Now, I'm going to make the assumption that if I'm not going to run any miles, I don't think that's going to take any minutes. So I'm going to go ahead and make this a proportional relationship. And we do get to make some assumptions when we draw a trend line. Even though I don't have any dots for running 0 miles, I'm going to start my line there at the origin. And I'm going to draw a straight line. Now, you're going to line your ruler up, and it kind of goes through the middle of just about all these dots. And I'm going to say that that's a pretty good trend line. It kind of goes through the middle. And from that, we can start to make predictions. So this example asked me, how long do you think it would take Joyce to run 4.5 miles? Now, if I look at my chart, I can say, well, 4 miles took 45 minutes. And 5 miles took 55 minutes. So somewhere in the middle of there, here's 4 miles at 38 minutes. Somewhere between 38 and 55 is probably correct. So let's come over to where 4.5 miles is. Here's my miles. So here's 4.5. And if I read up on the graph, I'll find that it hits right about there. And if I read across, it's going to tell me about how long it takes to run 4.5 miles. In this example, I'm going to say that if this right here is 45, I'm going to say that that's about 47 minutes to run a 4.5 mile jog. All right, let's get down to the meat and potatoes of this lesson, which is this. Can I create an equation for a trend line and then use it to make a prediction? So we're taking a look at this graph, and right away I notice that we're comparing pages and chapters. And since it's a positive relationship, I can assume that the more chapters I add to a book, the number of pages in the book will probably go up. And I think most people will agree that that's true. If you have more chapters, you probably have more pages. And I also look at this trend line and I notice it goes through the middle of all these dots, meaning I have 1, 2, 3, 4 dots that are kind of below, and I have 1, 2, 3, 4 dots that are kind of above, and I have a couple of dots that look like the line go right through it. So we're going to pick 2 points on this graph, and we're going to find the slope. Now, I know that my dot here, I could kind of maybe count to this, but I take a look at this line, and I notice the line starts at 0. So I'm going to go ahead and use that as a point. Even though it's not a point on my line, on my graph, as in the scatter plot, the line actually goes through that point. And I'm going to use this one too. And I don't want you to confuse what I'm doing. In fact, let me change colors. What I'm adding isn't part of the scatter plot, but I am using it to find the slope. And so if I want to count my rise and my run, I notice that I go up. I'm not just going up one line, I'm really going up 20. And when I go across, I'm really going over 2. And so my rise, in this case, is up 20 because from 0 to this first line is up 20 pages. and I go across, my run is 2. So my slope is really 20 pages in 2 chapters. And if I reduce that fraction, I can now interpret that to mean that on average in this scatter plot, there are 10 pages per chapter. And that's my slope. My slope is 10. And let's go find the y-intercept. The y-intercept is where the graph starts. And I can see right there that the graph starts at the origin. This is a proportional relationship. The y-intercept, which is given by the letter b, is 0. And so the equation for the line is y equals, and my slope was 10, so it's going to be y equals 10x. I'm not going to write plus 0. It's just a proportional relationship. And that shows that there's 10 pages in a chapter. We're going to take a look at a couple more examples about how to write an equation for a trend line based on a scatter plot. So I have my scatter plot here. You can see that I have the dots kind of scattered above and below. The trend line goes right in the middle. And so now it's time for us to take a look at what an equation for this trend line might be. I got a little mark on my graph. So the first thing we want to know is, where does the graph start? If I take a look at the graph starting, it's on the y-axis here. We're going to find the y-intercept. If this is 160, this number here is 200. That makes this next line 180. And since this line starts in the middle of 160 and 180, I know that my y-intercept, my value for b, is 170. So that means that according to the scatter plot, I have 170 kilometers remaining on average when I started my ride, and then we're going to ride this thing out in hours. So the average person had about 170 kilometers to ride. And then I'm going to look down this graph and I want to find out, is there another dot somewhere that I can count to? And I notice that my line doesn't go through a point there and doesn't go through a point there, but it does right here, and this is the one I'm going to count to. So I'm going to go ahead and put a dot around that one. I'm going to make my dot. That's what I'm going to count to. And I'm going to count my rise. Now my rise is from 120 up to, and this line right here I'm looking at, my line starts at 120, it goes up to 170. So my rise is going to be 120 minus from 170 is 50. So my rise is 50, and my run is going to be, it's going to go all the way back across here to that line, to that point. And it started at 2 and it went back to 0. So it was 2 hours. So it started at 2 and it went back to 0. And I know that since my trend line is going down, this is going to have a negative slope. Now 50 divided by 2 is 25. So my rise is negative 25. And since my slope is in kilometers per hour, so it's negative 25 kilometers per hour. And the equation I have will then be, remember our generic form for a slope-intercept equation, y equals mx plus b. Well, there's m, it's our slope. I should have put run right there. My run was 2. So the equation I'm going to get, y equals negative 25x plus 170. Here's one last scatter plot we're going to take a look at, and it's about the cost of a cell phone plan, and it's comparing the cost of your bill in dollars. So here's our dollars over here, and they're comparing that to the number of minutes that you get in your plan. And we can see that there's a positive trend. The line is going up. We've got a couple of outliers, dots that really just don't fit a pattern at all. I'm going to just circle them right there. There's an outlier, it's pretty high. I don't know if this is right here is an outlier. They're not terribly far off the pattern. But sometimes we just see a dot lying around out there somewhere, and we kind of refer to that as an outlier. And that's about as technical as we need to get for now. Let's take a look at this graph, though. We're going to find, we need to find two things. We need to find the slope, and we need to find the initial value. The initial value is kind of easy to see in this graph. You can take a look on the y-axis. Take a look at where the graph starts. The graph starts right here. And if this is 10 and this is 20, this one's in the middle. And so the initial value is $15. And that means for no minutes, the average plan on this scatter plot costs $15. So the initial value is 15. That's our B, that's our y-intercept. I'll just put a B in parentheses so that when we write our equation, y equals, we know that our B value, our initial value, is going to be plus 15. Let's go find the slope. I'm going to go ahead and start counting there because that's a nice easy number to count from. So I'll put a dot there and I'm going to just count. I'm going to look. I can't really count to that, but this one right here, I'm going to count to this dot too. If the line comes pretty close, that's going to be good enough for us to count because we're just trying to get about an estimation of the value. So I'm going to draw a triangle up and I'm going to draw a triangle across. It's kind of hard to see. Let me draw that in a different color. We're going to go up. I go from 15 up to 20. So my rise from 15 to 20, my rise is 5. So my rise is 5 and my run is from here to here is 200. And so that means every time I add 200 minutes, my bill goes up $5. Now we're going to go ahead and reduce that. I'm going to divide the top and the bottom here by a 5, and that becomes 1 over 40. And so I could write the equation as y equals 1 over 40x plus 15, meaning for every 40 minutes that I add on my bill, my bill goes up by $1. And this will be okay. This will be fine for an equation.